Okay, so here we are, 7 more questions on this mixed exercise chapter, chapter 6. So question 19. Okay, circle has an equation that is x squared plus 6x plus y squared minus 2y equals 7, and the lines L1, L2 are tangents to the circle. They intersect. L1 and L2 are tangents and intersect at point R, which is 0, 6. Okay, find the equations of the lines L1, L2, giving your answers in the form y equals mx plus c. Okay, so they've given us a picture, thankfully. All right. So we've got something like that. We've got a point A here-ish, and then we come around here and we've got something like that. This comes through here. This one comes through here. It's meant to touch. That's point P. That's point Q. P, Q, L2 is this line. L1 is this line. This is the circle C. That's the origin, and it has a center A. Okay, and we are told this is point R, which is 0, 6. Okay. So ultimately, we already have a bit of the equation for these, which is y equals mx plus 6, because we're told that they meet at that point and they both go through that point, so we've got the point 6, or the 6 there. So what we can do is we can start solving simultaneously. So let's take the y and we can start putting into this. Let's have a little look. X squared plus 6x plus mx plus 6 squared minus 2y, which is mx plus 6, I don't know what the m is yet, equals 7. A little bit of multiplying out to have a look to see what we get. Mx plus 6x equals m squared x squared plus 12 mx plus 36 minus 2mx minus 6, and I'm going to bring the 7 over, minus 7 equals 0. Okay, that was the 7 from the end there. All right, bit of tidying up here. I've got x squared. What's that? That's going to be a plus, I think. Okay, so I've got x squared plus mx squared. Okay, plus, that's the only thing with an x in it at the moment, 6x, and then I've got this 12mx minus 2mx, so that's a plus 10mx. And then numbers on their own, 36, take away 6 is 30, take away 7 is 23, equals 0. So, looking at this now, the trick, and it is literally feels like a trick, is to say that x squared can be a factor of 1 plus m. So I can take an x squared out of these two terms here, and I can do the same with the 6 on here, and I can get plus x times 6 plus 10m plus 23 equals 0. That looks very like a quadratic, which means I can start putting it into the quadratic formula to solve it, but I don't need to solve it, I just need to put it equal to 0. I need to do the discriminant equal to 0, which is b squared minus 4ac is equal to 0, because when it's equal to 0, it only has one solution, which a tangent has only one solution. And when I do that, I end up with b squared. So b would be 6 plus 10m. 6 plus 10m squared minus 4 times a, which is 1 plus m, times 23, which is the c. That equals 0. Move this up a little bit. Which now, multiplying that out, 36 plus 120m plus 100m squared, 23 times 4. 23 times 4 is 92, so minus 92 minus 92m equals 0. 100m squared plus, so 120 take away 92 is 28, and then 36 minus 92, 36 minus 92 is minus 56, and that equals 0. Okay, solving that for m equals, and m equals, because that's what I'm looking for in terms of y equals mx plus c. Straight onto the calculator, onto the polynomial solver. Okay, 2 degrees. Here we go. 100 into there, 28 and minus 56. And not entirely sure that's correct. Let's see, minus 7 minus 3 square root 161 all over 50. And needless to say, minus 7 plus 3 square root 161 all over 50. And if I wanted, that's a 0.6, and x2 is a minus 0.9. Okay, let's go check those results. So that is not the correct answer. The question is where is the mistake? I'd like to say I put it in on purpose, but I didn't. Okay, it's just a mistake. Up here, we had m squared x squared, and on the next line, we've got mx squared, but that should actually be m squared there. Which means that when you do the factorization, you get m squared again. Which means as you come down here, we end up with a 1 plus m squared being multiplied by the 4 and basically the AC part of it, which changes 92m into 92m squared. So we can take away all of this last 3 lines or so, which are going to be affected by that and be wrong. Okay, and now just redo the last quadratic that we had here. Okay, so 100 take away 92 leaves us 8m squared. Okay, it's now a full 120m, and it should still be 36 minus 92, leaving us minus 56 equals 0. Putting those new numbers into the quadratic solver, 120 into this one, and minus 56 stays the same on this one. And there's still a problem. What have we done wrong now? 120 take away 92 is not 8, is it? Okay, that's what you get for rushing. All right, so 120 minus 92 should be 28. Where's my 28. So putting those in, 28, 120 minus 56. This is going horribly wrong. I think clearly we need more coffee. Okay, so where's the second mistake in all of this? As you continue to multiply out, minus 2 times mx is minus 2mx. Minus 2 times 6 is minus 12. Okay, which means as we then look at a solution coming down here, that's obviously going to have a bearing on various things. So we've got 36, take away 12, take away 7, which gives us 17, not 23. Okay, which means that continues down into here, which means we come into here. Okay, 4 times 17, 4 times 17 is 68. So we should have 68 on here and 68 on here. Okay, which again changes this solution. Okay, don't mind showing where I make mistakes. Okay, and feel free to comment and yes, make fun of me basically. Okay, so 100m squared take away 100m squared take away 68 is 32 m squared. Then we've got plus 120m, and now we've got 36 take away 68. All right, minus 32. Hopefully we will get the correct solutions on the polynomial solver. Okay, put it in. 32, 120, and minus 32. And we get m is equal to a quarter. And having seen the answers at the back of the book, I know these are correct. M equals minus 4. Okay, which gives us the two solutions for the straight line graphs, which is y equals a quarter, x plus 6, and y equals minus 4x plus 6. And just looking at the graph, L2 is the quarter, and L1 is the 4. Okay, that was only part A. Part B then, hopefully with less mistakes. Okay, part B. Find the points of intersection of P and Q of the tangent of the circle. Okay, so now that we know that we've got the intersections here, and we've got where they are equal to after putting it into the equations here, we can substitute in the m values into this line here, okay, so that we can find the x values of there. Okay, so taking that line there, okay, taking that line there, and obviously we have to do this for an m of a quarter and m of minus 4. Okay, so we end up with, did I miss a bracket on that? It looks like I did. Okay, so x squared 1 plus a quarter squared plus x 6 plus 10 quarters plus 17, okay, equals 0. Okay, 1 plus a 16th, so 1 and a 16th x squared plus, what's that, 2.5 plus 8.5 x plus 17 equals 0. So um, 1.065, 8.5 and 17 gives me solves of x equals 4 and x equals -4, and that is all. Okay. We can then do the same for -4, so x squared 1 minus 4 squared plus 6 plus 10 times 4, 40 minus 40 x plus 17 equals 0. So 16 plus 1, 17, 17x squared minus 40 plus the 6 is minus 34 plus the 17 equals 0. Into the solver. Okay, 17 minus 34 and 17 again. That one's probably quite obvious, isn't it? X equals 1. Okay, so now that we've got the two solutions for x, we can substitute them in to find y's, and we can use the straight line equations to do that, just to make it easier for us. So y equals a quarter times minus 4 plus 6. That becomes minus 1, which means y equals 5. And on this one, using the L1 equation, y equals minus 4 times 1 plus 6, giving you a y of minus 4 plus 6, giving you 2, meaning that your points for P are going to be minus 4, 5, and your point for Q is going to be 1, 2. And looking at the diagram, that looks to be about correct as well. Okay. Find the area of the quadrilateral APRQ. Let's have a little look at what that is. APRQ. APRQ. So we have something like that. All right. Let's see what we can do. We can add the, we can find the distance of AP, we can find the distance of PR. We can then use that to do half the base times the height to give us the triangle. Both triangles are the same. We don't need to do the half. Okay, so literally the length of this red line here, we'll just make it blue just so we know, the length of the blue line times the length of the yellow line will give us the area of that. Okay, so let's see, do we have a point A? Should we do? So it looks like we could do with doing a point A, finding point A and going from there. Or do we know the radius of the circle? Not yet, not without some rearranging on it. Okay, so we'll do both of those and then see what we get. Okay, so starting with the equation of x squared plus 6x plus y squared minus 2y equals 7. Okay, let's take in just do like a difference of squares on this. So what we want to do, like a x plus 3 squared. Now that's going to produce a 6x, which is great, but it's also going to produce a 9. So we need to take away 9, and then a y minus 1 in there. Again, that's going to give us a minus 2y, but it's going to give us an extra plus 1, so we take away 1, which equals 7. So we end up with x plus 3 squared plus y minus 1 squared equals 7, 8, 16, 17. So we find that there. So that gives us the length of, so that gives us the point A is going to be minus 3 and 1. Okay, and the radius is going to be equal to the square root of 17. Okay, so now that we've got that, we can do the points between P and R. So point P, did I write point P down somewhere? There it is, minus 4, 5. P is minus 4, 5. R is 0, 6. So the difference is between there and there, the square root of, for length of PR is equal to 4 squared and plus 1 squared, 16, 17, which is equal to square root of 17 again. Looks like it was a square. So multiplying 17, square root of 17 by square root of 17, okay, square root of 17 squared equals 17 units squared for the height of it. Okay. Ha, just realized we had the two straight lines which had a slope of 4 and a slope of minus 4 and a positive quarter. That clearly means that they're 90 degrees if we knew it was a square to begin with. Okay, doesn't matter, showing it anyway. Okay, let's stop there.